But starting today, we're doing antiderivatives. And that doesn't mean like you're against derivatives, right? Some of you are like, yes, antiderivatives, sign me up, I am antiderivative. No, it means the opposite process of taking a derivative. Yes, that's another name for it. And so antiderivatives, even before I pass out notes and we start taking notes, is sort of like driving in reverse. This is the analogy I go with. Like the better you can drive forward, right? Like I'm guessing all of y'all are competent at driving forward. The better you can drive in reverse. So you're all like, yeah. But driving in reverse is still like, right? Like go a little bit slower, be a little bit more careful because it's trickier. You're just not used to it. All the rules are the same, but it's like backwards, so it's tricky. When I was in high school, we had one of those long single driveways that had a turn to it, and so like backing out was like, I could do it. I don't know that I ever went into the grass, but I always went really slow because you got to be careful going backwards. And that's sort of the name of the game today. Like, you know all the rules. There aren't any new rules to learn, but you got to slow down because you're going backwards, and if you go too fast, you make a mistake and hit the mailbox. And hopefully none of y'all have done that, and hopefully you won't do it in here. But again, you know all the rules. Just go slow because it's backwards and things just feel a little bit weird in reverse. On the other side of that is if you're good at taking derivatives, if you feel like you're pretty good at knowing the rules, then going backwards is not a big deal. I mean, you still need to slow down a little bit, but you'll be fine. If you don't know how to drive forward, meaning if you don't know your derivative rules, then driving backwards is just going to be impossible. So I don't think anyone's in like that bad of a shape, but if there are rules that you struggle with, then when we hit those in reverse, it's going to be really, really hard. So the better you drive forward, the better you drive backwards, but go slow and be careful. All right, antiderivatives. Driving backwards. Notes today are not really that long because, again, if you know how to drive forward, you know how to drive backwards. It just takes practice, and you better slow down. And so that's what we'll do today. Is like it's not hard stuff. There's really nothing new. It's just using all you know in reverse. All right, we know that if f of x is 2x cubed, then the derivative is 6x squared. Right? Bring the power down, decrease the power by 1. Got it. But what if we're trying to go the other way? Thank you. What if we know that the derivative is 4x cubed, so like we know the answer, we want to go backwards to figure out the function? Well, that's the word antiderivative, so underivative, go the other direction. Like you know the derivative is 4x cubed, what would the function have been to get 4x cubed? X to the fourth. Gave you kind of an easy one there, but that's because it's the first one. So thinking backwards, you increase the power by 1 and divide by the new power. We'll say that in a different way here in a minute. So we can say that the antiderivative of 4x cubed is x to the fourth. Right? The antiderivative, the opposite of the derivative, the going backwards derivative. Now, this next line is super important, and it's part of what makes going backwards different, trickier. Are there any other functions whose derivative is 4x cubed? And the answer is yes, and they're all similar. And it has to do with what function has a derivative of 0? What kind of things have a derivative of 0? Constants or numbers. So if I had x to the fourth plus 7, its derivative would still be 4x cubed. Right? And if I had x to the fourth minus 3, its derivative would still be 4x cubed. And if we had x to the fourth minus, would just be kind of crazy here, minus pi squared. Pi squared is still just a number. Its derivative would be 4x cubed. And so, because constants have a derivative of 0, when we go backwards, it's like we can't recover the constant. We don't know what the constant was, because the derivative wiped it out. If you go backwards, it's lost. I don't know what it was. We can add any constant to your antiderivative to get another function whose derivative is still 4x cubed. This constant we label c, and we call it the constant of integration. So when you're asked for an antiderivative, you sort of figure out the answer, x to the fourth, but then you have to include plus c. You've got to include the plus c, because that will account for the constants that might have been there that have since been erased, and we don't know what they were. So we just say plus c, and that covers all of them. All right, a little note on notation. We denote antidifferentiation, that's a fancy word, antiderivatives, with an integral sign. So that little elongated s there, that's where it comes from, and we'll talk about what that s, why they picked an s on Wednesday next week. That just means take an antiderivative. So in the above example, we write the antiderivative of 4x cubed. The dx is still with respect to x. So looking at x as our variable, let's see, that would be x to the fourth plus c. Why the dx matters is an example here to show that. What's the antiderivative of 4 dx? Who has a derivative of 4? 4x. And then plus c. Well, what about the antiderivative of 4 dy? Who would have a derivative of 4 if we were taking a derivative with respect to y? It'd be 4y. It's not 4x anymore, it'd be 4y. So almost all of ours are x, because that's usually what we're doing, but that shows why that dx is important. So basically, if it's a dx, like just work the problem like you normally would. If it's something other than dx, then you better slow way down and figure out what's going on. If g of x is an antiderivative of f of x, meaning there's more than one, then we could say the antiderivative of f of x is g of x plus c. Okay, here's the power rule. Now, you kind of already know the power rule, but we're just going to try to work it in reverse. If we're taking the antiderivative of x to the n, instead of decreasing the power by 1, we're going to increase the power by 1. Right, because this is the opposite of the derivative. And instead of multiplying by that power, that's the derivative rule, we're going to divide by the new power. Increase the power by 1, and then divide by the new power. So everything is reversed from the derivative rule. Right? The derivative rule is multiply by the power and then decrease it by 1. The antiderivative rule is increase it by 1 and then divide by the new power. All right, this box is starred, but I'm going to say you should know these. Who has a derivative of cosine? Sine. And then don't forget the plus c. Who has a derivative of, you know what, let's go down the left-hand column first. Who has a derivative of secant squared? What's that? The derivative of tangent is secant squared. plus c. And who has a derivative of secant tangent? Secant. So again, those are the rules that we already know, but we're using them in reverse. Okay, be careful on this side. Who has a derivative of sine? Cosine is sort of the answer. Negative. Right, because the derivative of cosine is negative sine, so I put a negative on there to wipe out the negative. Who has a derivative? What is the antiderivative of cosecant squared? Well, look at the parallel, cotangent, but negative, and then plus c. And then who has a derivative of cosecant cotangent? Cosecant, but negative. The antiderivative of tangent, we don't know how to do that yet. I mean, I know the answer, but we haven't got there yet.
So will I know later?
Yes, you will know later. Yep. And that's one where you'll either memorize it or there's a way to figure it out. Because tangent is sine over cosine. We will leave it alone at that for now. It's harder than the others because it's not an easy answer. Like we'll get there, just not yet. Okay, some examples. Antiderivative of 8x cubed minus 9x squared plus 4. That's like 3 different pieces. Let's see here, I guess. Go one piece at a time. So let's increase the power by 1. That gets us to 4. And then divide by the new power. Right? Increase the power by 1. Divide by the new power. Increase the power by 1. Divide by the new power. And then some of them you don't like follow the strict rule, you just think about it, like who has a derivative of 4? 4x. And then again, don't forget the plus c. I guess that's a safe stop, but let's clean it up. 2x to the 4th minus 3x cubed plus 4x plus c. How could you check your answers on these? Take the derivative. Like, oh. So most people don't show checking their answers, but a lot of people do check their answers because it's really easy for the power rule. Like, you've done that so much, it's really easy to look at this and say, all right, the derivative of that would be 8x cubed. Got it. The derivative of this would be 9x squared. Yep. And the derivative of 4x is 4. So that's an easy one to check without showing a bunch of work. Okay, we've run into this root thing before, and we don't do derivatives of roots, and we don't do antiderivatives of roots. We much prefer powers. So what power is the 4th root of x cubed? How could I write that as a power? X to the 3/4. So let's see, increase the power by 1. So that would be 7/4. And then divide by 7/4, but that's a little clunky, right? What's an easier way to divide by 7/4? Multiply by 4/7. Plus, if you're thinking about checking, right away that makes sense, because 7/4 times 4/7 is going to go away. Decrease 7/4 by 1, and you get 3/4. So most of the time people are sort of checking as they go to make sure they've got it right. What about the antiderivative of 1? just be x, and don't forget the plus c. All right, there's not a chain rule for antiderivative, so I cannot take an antiderivative of that as it sits. How could I rewrite that? Yeah, let's make it 3x to the negative 7. Then use the chain rule. So why don't you try it, and then I will pick on someone that can tell us what they got. Increase the power by 1. Oh, dealing with negative numbers. Be careful. Anders, you'll be up, but feel free to check with a friend over there.
All right.
You got it?
I think I got it. He doesn't need to check.
He doesn't need to check. He's got it. What you got then?
I got negative 18x to the negative 6 plus c.
Let's see. I like the x to the negative 6 because we're going to increase the power by 1. I like the plus c.
Divide.
Yes. I think you multiplied rather than divide. So let's divide by that new power. Divide by negative 6. And I mean, that's a safe stop, but so negative 1/2 x to the negative 6. Or if we want to be kind of fancy, we could put that x to the 6 in the denominator. That's probably what the multiple choice question would do. So it's like there's only one rule. It's just we try to complicate it with negative numbers and with fractions, but it's still the same rule. Increase the power by 1, divide by the new power. On number 4, again, there's not really a chain rule for antiderivatives. So right now I kind of only have one option here. Before I antiderivative, what should we do? Yeah, FOIL it out, square it out. So I'm going to pause and let you try that one. Fine. All right, number 5 looks crazy with the thetas in there, but we're doing it with respect to theta. And if that really bugs you, you could replace all the thetas with x's and then do the problem. So what do you think the antiderivative of theta squared is if we're doing it with respect to theta? So it's the same rule. 1/3 theta cubed. Increase the power by 1. And divide by the new power. So theta cubed over 3, or 1/3 theta cubed. What about the antiderivative of secant squared? Who had a derivative of secant squared? Tangent. So plus tangent of theta, and then plus c. Number 6 kind of looks like a chain rule problem, but there is no chain rule for antiderivatives. So what do we do first? Either move the x squared up or just divide everybody by x squared, something along those lines. So 4x cubed plus 2x squared minus 1. Now that's not calculus, that's just algebra, but now we're ready for an antiderivative. Show that answer in number 6 there. Last one for today is 7, because number 8 is Monday. It's only one example, because we've got 2 days of practice basically. Because you know all the rules, it's just you need to practice. Again, the driving in reverse analogy. In theory, you know how to do it, but you only get better by, getting in the car, putting it in reverse, being super careful, and backing up. And so we're going to allot a couple of days to practice that. Back to number 7. Solve the differential equation. What? That sounds weird. F prime equals 4x squared, given that f of negative 1 equals 3. Okay, well, what that means is find f of x. So if I want to go backwards from f prime, if I want to undo the prime, then undoing the prime would mean taking an antiderivative. And so just like we can take a derivative of both sides, we can take an antiderivative of both sides. We can underivate both sides. Derivivate, whatever silly word you want to put there. So what's the antiderivative of f prime? F, right? The antiderivative of the derivative is f. Okay, it's like, oh, that's right. That's why we did that. That's like asking what's the square root of x squared. You're like, yeah, that's x. They cancel each other out. How about the antiderivative of 4x squared? Good. 4 over 3x cubed. Increase the power by 1. Divide by the new power. And then don't forget the plus c. Okay, so we haven't really solved for f of x yet because we don't know the c. But they gave us this information. Use it to find c. Use to find c. So that means if I plug in -1, my answer should be 3. So if I plug in -1 for x, 3 is my y value. Sometimes this is given as a point. They won't say f of -1 is 3. They'll say f of x goes through the point -1, 3. That means the same thing. So 3 in for y, -1 in for x. And so I got to add 4/3 to both sides. And that would be a safe stop. You don't have to do that if you don't want to. But hopefully adding fractions is not a big deal. So we're like, yeah, adding fraction is a big deal. Alright, so I know what c is. There's my function. Let's put those two pieces together. F of x equals 4/3 x cubed plus 13/3. This would be another one that you could check. So you take the derivative of that, and you would get 4x squared. Check. If I plug in -1, I would get -4/3 plus 13/3. That's 9/3. That's 3. So we're good. I had to check two things. I had to check that this was true, so I took a derivative, and I got 3 times 1/3 goes away, 4x squared. So that's good. And then if I plug in -1, I'm supposed to get 3. So -4/3 plus 13/3 would be 9/3. So that one's true as well. All right, today's assignment is worksheet 1. You can already see Monday's assignment. Excuse me. Monday's notes was short. Monday's assignment is worksheet 2. So if you're not here Monday, like you're prepared to do it, it's really just more practice of the same stuff.